All right, welcome College Math. Here is our first video for section 1.5, where we'll be talking about different types of graphs that you'll see that you would commonly see in statistical studies or even in the media. We still have section 1.6 after this, but we're going to go ahead and skip that one due to time. We are a little bit behind. And then because of that, section 1.5 is also going to be a little bit shorter than the other ones. So let's just kind of go through it. That way we can continue on with other things this week. So the idea of graphs is that once we've collected our data for our study, so we've designed our research questions, we've kind of taken care of, hopefully we've defined our variables, we've hopefully taken care of any confounding variables and stuff like that. We've gathered our sample from the population. We went ahead and either surveyed or did our experiment as part of our clinical study, or surveyed as part of our observational study. And now we have our data, so we're needing to analyze it. In chapter 2, we're going to talk about how to do some numerical analyses on it. And by that, I mean using our sample statistics to make estimates about population parameters, etc. But for now, in section 1.5, what we're going to do is we're going to see how we can organize our data into graphs to use that to make conclusions about our data that we've gathered. So some definitions to kind of kick this section off. We're going to talk about frequency and relative frequency quite a bit here. So frequency is defined as it's the frequency of a data value is how many times it occurs in a data set. So if I did a study on everybody's favorite fruit, all my data value isn't restricted to just numbers. It can be like any of the categories in your qualitative study, when we use descriptions or characteristics as our variables. If I'm talking about everybody's favorite fruit, then oranges can be a data value, apples can be a data value. We're talking about how many times these data values occur in a data set, okay? And then when we talk about relative frequency, the relative frequency of a data value is pretty much just the frequency divided by n, which if you remember from a few sections ago, is our sample size. Okay, so when we talk about relative frequency, we talk about the proportion of that data value compared to the whole. So if there were 100 people surveyed and I had 20 people that liked oranges, then my relative frequency would be 20 divided by 100, which is 0.2 or 20%, right? So you're gonna often see relative frequency as a percentage. Yeah, usually. It's gonna be a cramp. Okay, I was gonna say it's gonna be a little cramped. It's usually a percentage, okay? Now, when we talk about the frequency distribution, pretty much what we're doing is taking all the frequencies that we found and putting them in a nice little table. Okay, it's a listing of each data value with their assigned frequency. So I'm putting all my fruits in a table, apples, oranges, bananas, etc., all the ones that were in my study. And then next to it, I'm listing the frequency. I had 20 people that liked apples. I had 30 people that liked bananas, etc. And then pretty much the same exact thing when we talk about a relative frequency distribution. It's just another table, but this time we're listing the relative frequency instead of the frequency. Sometimes you're going to see table, and most often, just because it's a nice way to kind of put everything in the same place, most often you'll see tables that have both the frequency and the relative frequency. That way you get all the information you need. Okay, now depending on the type of variable that we're using, so remember we either have quantitative or qualitative variables, and remember other names for those are numerical for quantitative and categorical for qualitative. Depending on the type of variable, we're going to use a different type of graph. Okay, now some graphs you might already be familiar with are bar graphs, pie charts, line graphs, maybe histograms if you've kind of seen those before, box and whisker plots, etc. We're going to be seeing those a lot in the coming sections, okay? And especially in this section, we're going to talk about, we're going to start with qualitative variables here. We're going to be talking about how with qualitative variables, we will use either a bar graph or a pie chart. Okay, so let's just kind of, this might seem a little redundant, so just bear with me. You might have already seen a bar graph or a pie chart, but maybe you never have. Okay, so let's just kind of, let's make sure we're starting off on the same page before we continue. Define what a bar graph is and define what a pie chart is. All right, by a bar graph, it's a graph that uses rectangles to represent the frequency of each data value / class, right? And when we say class, I think I skipped that up. I skipped that over here. When we talk about grouping of data values, we call those classes. So sometimes, and we'll talk about this a lot with histograms, sometimes we like to group data values. So instead of just saying, the number 31, how many times does that occur? Maybe I want to care about how many times the numbers 31 through 35 occur. We'll talk more about that once we get to the quantitative variables. All right. So yeah, with bar graphs, we would represent the frequency of each of the data values / classes in the data set using rectangles. And that makes sense, right? Whenever I make a bar graph, if I make a crappy little one right here, whenever I make a bar graph, usually I have like my markings right here, and then however many like apples my friends liked. If there was 4 of them, then I would make a bar that is 4 units tall, etc. Right? And then I would label the y-axis, I would label the x-axis, etc. And then the bars, you can make the bar graph either vertical or horizontal. Typically, we see the vertical display, but you can definitely make it horizontal if you'd like. And then we also have the pie chart, right? And the pie chart, you've seen those as well. And it's a graph where the pie, like the entire circle, represents our entire sample, so however many people we surveyed. And then each of the slices represents the proportion that each category / class contributes to the sample. So, you see the 20%, the 30%, that is the percentage of the entire sample. So then because of that, we often use, not often, we almost always, at least include our relative frequency when we do pie charts, our percentages, our proportions. Now, sometimes you'll see pie charts that list both the percentage and the total, which is nice. Like it'll always be nice to see those two, but more often than not, you just see the percentage. Okay, so let's go ahead and let's make some bar graphs and pie charts. All right, here's our first example. Frank asked all of his classmates what their favorite soft drink was. He found that 9 of them like Coca-Cola, 10 of them like Pepsi, 5 like Mountain Dew, 4 like Dr. Pepper, 3 like Sprite, and then 2 of them do not like any kind of soda. So let's create a table that includes the frequency and relative frequency distributions of the above data. Sorry about that. So we're going to go ahead and make a table, and we're going to include both the frequency and the relative frequency. All right, so let's go ahead and do that. So whenever we do this, we're going to want to make sure that we have, oh God, let's try that again. That was a very shaky line. We're going to want to make sure that we're including 3 categories here. We want to, in this case, we're talking about soda, we're talking about soft drinks, so we need to make sure we have our soft drinks available to us, labeled. And then we're going to do our frequency. And then we're going to do our relative frequency. And we might need a little bit more space for that one. So we'll give it as much space as we can because we're going to do some calculating. Okay, so we're going to need to make sure we total up all our values first, all the numbers from above to find out what our total sample size was. It doesn't always tell you what your sample size is, so we got to make sure we do that first. So not too complicated. We just do 9 plus 10 plus 5 plus 4 plus 3 plus 2. All right, and when you do that, you get 33. I think. I'm gonna double check that to make sure. 28. Yeah, 33. So that's our sample size. That's our n. Okay, and we're gonna need that for relative frequency. So just for funsies and for convenience, we'll list the sample size next to our frequency. So then let's go ahead and put in our drinks. Here is Coca-Cola, Pepsi. What else do we got? We got Mountain Dew, Dr. Pepper, Dr. Pep. Sprite, and none, because we got people that don't like any soda. And then, like I said, frequency is just the amount of times that one data value occurs. These being our data values, our sodas being our data values. 9 people like Coca-Cola, so 9. 10 people like Pepsi, so 10, etc. Right? 5, 4, 3, 2. Frequency, pretty easy. It changes when we do relative frequency. We got to do an extra calculation. And remember, our relative frequency is our frequency divided by n. So we take for Coca-Cola, we do 9 divided by our n, which is 33. And when we do that, we get 0.27. We're going to round that up to 3 because we get 27 again. 1 decimal place is fine enough here. And then as a percentage, because we'll need that eventually, 27.3%. And we do the same thing with all the other ones. We'll just I'm just gonna kind of fill these out as we go. You probably already have most of these done, so you can fast forward if you need to. But we'll go ahead and fill these out. Like I said, you're just dividing each of these frequency values by n. That's going to be 15.2. Hope you all are having a lovely day / morning / night whenever you're watching this video. It's going to be 9.1. 2 more. Hopefully, if you've already gotten this done, you fast forwarded. Ooh, I skipped, sorry. My bad. This is actually supposed to be 12.12. My eyes wandered. I cheated a little bit. I have this done already. There's our 9.1, and then our last one, 2 divided by 33. There is our, that's a 0, 606. Here's our 6.1%. Okay, so there is our table that shows the the frequency and the relative frequency distribution. Okay, not terrible. Let's continue. We're gonna make a bar graph using this stuff. All right, so it's important that when we make our graphs, and remember, we talked about this in section 1.4 when we're asking ourselves, should we believe the statistical study? Should we believe the data that's being showed to us, or the results of the data that's being showed to us? And a lot of times you're going to see graphs. And whenever you're, part of a study, or when you're presenting your data, your graphs have to be very descriptive. They have to tell the exact story. Sometimes, people like to tell a different story using numbers. Numbers can be twisted to be done many different ways to tell many different things. So then you want to make sure that if you're trying to get a specific point across, that you make sure that your graphs do exactly that, right? For us, we're just trying to get the point across of soft drinks. So we got to make sure that our graph says things about soft drinks and number of people, etc. All right, so we just need to draw ourselves a cute little first quadrant. Our y-axis, it's the number of people, right? Since there were people, Frank asked his classmates who like what soda they like. So our frequency is technically like people. We're gonna scale this. I think the best would just be scale it by 2, 4, 6, 8, 10, 12. We don't need to keep going that high. And then down here, we're gonna label our drinks. So we have Coca-Cola, we have Pepsi, Mountain Dew, Dr. Pepper, Sprite. Am I forgetting one? Nope, just we need the none category as well. Okay, and then even though you've labeled the horizontal axis with the specific data values that you got from collecting your data, you also need to make sure you just label the overall horizontal axis. What is being represented here? I don't know, like you can just say soft drink or soft drinks. Or yeah, you can, that's good enough, soft drinks. And then now we also need to make sure we're labeling the values as well. You can scale the vertical axis however you see fit. Like I decided that I wanted to do by twos. You could, if you were smart enough or smarter than me, you would have, made it by, drawn it a little bit higher. And that way I could use each of these little boxes as ones, but it doesn't really matter. You just got to be careful. I'm slipping in a little bit of 1.6 in here that we make up for lost times as we're not doing 1.6. If you're watching, the news or you're looking at graphs in social media, from news outlets and their social media accounts, you got to pay attention to the vertical axis because sometimes they'll scale it accurately to show here's objectively what's going on. Sometimes they'll change the scaling based off what they want to show. So they might make the scaling, they'll change it to make the line graph or whatever, or the bar graph show very drastic changes, because then that makes you think, oh my God, those are huge changes. But then you'll notice that the scaling on the left is just going from like 1 to 2, which is not really that big to begin with. They can also scale it the other way. They can scale it so that, it doesn't look like there's a lot going on, but really, they scaled it from like 1 to 1,000,000. So there is a lot going on just not being showed, right? So that's what we mean by being critical of the graphs that you see. Paying attention to the scaling, there will sometimes be scaling on the horizontal axis, like when we do line graphs. But when we're doing bar graphs, it will only be scaling on the vertical axis. Just kind of keeping an eye out. Not everybody who publishes graphs does it, but it's better safe than sorry. So now we just draw our cute little rectangles. Coca-Cola up to 9, so there. A little bit lower, but who cares? For the example, you should care when you do your assignment. Pepsi up to 10. Mountain Dew, we're up to 5. If you did this while I was on my little soapbox, and you can fast forward to when I have the completed bar graph. And then Sprite has 3. And then none has 2. Okay, so there's our very crude bar graph. You can fill this in if you want. The last thing that's missing is a title. Okay, whenever you make titles, you want to be as descriptive as possible. For this one, we can say favorite soft drinks. And since this was Frank's classmates, you can say in Frank's class, right? And so you want to be as descriptive as possible. If I just put favorite soft drinks, whose favorite soft drinks? Your friends, the people at Fry's, the people in the front office, who, right? You want to be as specific as possible. So whenever we're titling things, you want to make sure not every single, fine detail is included, but it summarizes kind of what's going on in this table. Okay. Now let's go ahead and do our pie chart. All right, well, it's going to be it's going to be a little crude here. To do our pie chart, it might be nice if we could pull from our relative frequencies. So we have Coca-Cola, Pepsi, sorry, almost skipped one, Mountain Dew, Dr. Pepper, that's a D, Sprite, and none. I don't have to make a formal table, just gotta grab our relative frequencies, 27.3%, 30.3%. Mountain Dew is 15.2%. Dr. Pepper, 12.1%. Sprite was 9.1%. And then none was 6.1. Now, if you notice, if we add these up, they don't exactly give us 100, but that's because I did a little bit of rounding. I was a little bit lazy. If you report out to the second decimal place, that'll get you closer to more accurately to the 100%. So that is something else. I'm kind of modeling all the bad behaviors you need to look out for when you're analyzing graphs. That's another thing you want to look out for. Make sure that because an actual person who's doing a study will be a little more careful and make sure that the percentages add up to 100% or that the proportions add up to 1, right? So we'll draw a little circle here. And if I'm correct, it'll auto-correct my circle. It didn't, but it's okay. It's a pretty decent circle. And then, you're gonna just pretty much try your best here. It's not going to be as exact, but we're just kind of shooting for a decent picture. So Coca-Cola, or actually, so let's start with the biggest one, Pepsi, at 30%. If we know this is a quarter, here's our center. We know this right here is a quarter, so it's a little bit more than that. I would say about there. So here's our Pepsi section. Let's color it red. Okay, so Pepsi at 30.3%. And then we have Coca-Cola, which is at 27.3%. So it's a little more than, again, the quarter. So I would say probably about, maybe like right here. We can color that one green. Coca-Cola at 27.3%. Okay, and then we got our Mountain Dew, which is at 15.2. So at this point, it's kind of just like, as best as you can. When you run actual studies and you're doing an actual report for like your job, or whatever the case might be, you have computer programs to make these look really gorgeous and not like a DE college math high school student drew it while taking notes. Or better yet, like the DE college math teacher did it while doing notes. Because yours actually might look better than mine. So you just kind of keep that in mind. And then Dr. Pepper, that's like 12%, so it'd be a little bit less than this one. Here's our Dr. Pepper. Dr. P at 12.1%. And then our Sprite and our none, I would say about that. Running out of colors here. No big deal though. Sprite at 9.1%. Ooh, and then I'm gonna use that rainbow color from the palette down here. That looks pretty for none. At 6.1%. Okay, and then you would give this a title. You could title it the same way you did for the bar graph. You can say favorite soft drinks in Frank's class. And then, like I said, here you could also, below each of the categories, you could write the actual total for each category. So like below 12.1%, I could have wrote the actual frequency number, which was 5, I believe. No, 4 for a Dr. Pepper. And then instead of doing this where the label is popping out of each section, I could have a legend at the bottom and just kind of tell you where everything is based off of the legend, and then still have the percentages jutting out of each section. I could have the percentages inside. I can have the entire labels kind of inside each of the sections. Lots of different ways you can do it. But yeah, Hopefully that sounds okay. We'll talk about the, down below there, we'll talk about quantitative variables and the graphs you can make for those in the next video. See you there.